All right, so Unit 4 Day 1 is all about compound inequalities. Now, a compound inequality is when two inequalities are joined with the words and or. So when you have an and compound inequality, an and indicates that both statements of the compound inequality are true at the same time. It is the overlap or intersection of the solution sets for the individual statements. To graph an and situation, only shade where the individual inequalities overlap. So again, with an and situation, it's the intersection between the two inequalities. Meaning, if I look at these two inequalities, where do these two inequalities share the same x values? Now, with an or situation, an or indicates that as long as either statement is true, the entire compound sentence is true. It is the union between the two inequalities. Now, to graph an or situation, shade everything that either individual inequality touches. So what we're going to be doing now is identifying solutions of and/or graph. So I'm looking at number 1. I have x is greater than 4 and x is less than 10. Now, here's the thing. What I'm going to do is I'm going to graph both of these inequalities above the number line and then look at where the solution is at. The solution will be on the actual number line, and that is what I'm going to be focusing in on as I am writing my interval notation as well. So let me go ahead and tell you what I mean. If I have x is greater than 4, first of all, 4 is located right here on the number line, and 10 is located right here on the number line. We need to remember all of those rules that we talked about when it comes to graphing inequality. So if I have x is greater than 4, that greater than 4 means that the 4 is not included. It's an open dot, and I'm going to be shading to the right. So notice that I am graphing the inequality above the number line because I want the actual solution to be on the number line itself. Okay, so 4, it's an open dot. I'm shading to the right. Now at 10, it's the same thing. It's an open dot, but since it's less than, I'm going to be shading to the left. All right, so I have these two inequalities drawn out. Remember, we are dealing with an and situation. The and means intersection. Where do these two inequalities overlap? So I need to look at both of these inequalities, and I can see that they overlap right here. All right, so that's the solution. That is what I'm going to be putting on our number line. So we know that 4 is an open dot, and 10 is also an open dot, and the solution is between 4 and 10. Okay, so I have my solution now. Let's go ahead and write the interval. Remember, when we write the interval, we read from left to right. We only care about the solution. So since I have 4 and 10, I start at 4 and I end at 10. 4 is an open dot, so it gets a parentheses, and 10 is an open dot, it gets a parentheses. 4, 10 is the interval for number 1. Number 2, we have x is greater than 4 or x is less than 10. So 4 and 10 are the main characters. I am going to have an open dot at 4, and I'll be shading to the right, and I have an open dot at 10, and I'm going to be shading to the left. Now, with an or problem, you need to remember that we're going to be shading everything that either individual inequality touches. So what are all the x values involved? I'm not looking for the intersection. I'm looking at all of the x values that are pertaining to number 2 here. So if I look at x is greater than 4, we start at 4. It's an open dot here, and we are shading to the right. Now, as it approaches 10, 10 is going to be included. So that open dot now becomes a shaded dot or a closed dot. So 10 is going to be included because, look, 10 is greater than 4, right? So that's going to be part of the solution set. And then to positive infinity. Now, with x is less than 10, it's an open dot. And as I approach 4, that open dot also becomes a shaded dot because we know that 4 is less than 10, so it's going to be part of our solution set. So again, that open dot now becomes a shaded dot. And then we're going to keep on going to the left here. So as you can see, this is going towards positive infinity, and this is going towards negative infinity. So it looks like all of the x values are going to be included for number 2, meaning it's an all real number situation. So let's go ahead and graph our solution set. So we have an open dot at 4 and an open dot at 10. Now, at 4, it's an open dot, and since x is greater than 4, I'm going to be shading to the right. And again, since I am approaching 10, that open dot now becomes a shaded dot because it's greater than 4. So x at 10, it is greater than 4. And then we're going to go ahead and proceed. Now, at x is 10, x is less than 10, right? I'm going to be shading to the left from 10. And since I'm approaching 4, that open dot now becomes a shaded dot. And then we're going to go ahead and proceed. All right, so it looks like we are going to go towards negative infinity and positive infinity. So we are going to read this from left to right. We're not starting at 4, and we're not ending at 10. We are starting from negative infinity. So negative infinity, comma, and it ends at positive infinity. Now remember, with negative infinity and positive infinity, we do not put a square bracket on them. We actually put a parentheses for each of them. Okay, so the interval is from negative infinity to positive infinity. Number 3, we have x is less than or equal to 4 and x is less than or equal to 10. So 4 and 10. At 4, since we have a less than or equal to, the 4 is actually included. It will be part of the solution set. And then we're going to be shading to the left. And then at 10, since it's x is less than or equal to 10, it's a closed dot there as well. And we're going to be shading to the left like we did with x is less than or equal to 4. Now, and, meaning overlap. Where do these two intersect? What are the x values they have in common? We can see that they overlap here. All right, and it's going to go towards negative infinity. So we have a closed dot at 4 and a closed dot at 10. And then we can see that the overlapping happens here. So I'm going to be shading from the left of 4, and it's going to go to negative infinity. So the interval notation, where do we begin? We begin at negative infinity, and then we're going to end at 4. So I'm just focusing in on the solution, the stuff that I'm shading on the actual number line. So we start at negative infinity, and then we're going to go and end at 4. So negative infinity, we get a parentheses for that one. And then for 4, we give it a square bracket because it's included. So the interval is from negative infinity to positive 4. Number 4, we have x is less than or equal to 4 or x is less than or equal to 10. So the main characters are 4 and 10 again. 4 is included, and we're going to be shading to the left because it's x is less than or equal to 4. Whereas x is less than or equal to 10, we're going to give it a closed dot. It's included, and we're going to be shading to the left as well. So, since we have an OR situation, that means we're going to shade everything that either individual inequality touches. So what are all the x values involved in this problem? So we have a closed dot at 4 and a closed dot at 10. At 4, I'm shading to the left, and it's going towards negative infinity. And then at 10, I am shading to the left as well, and of course it's going to keep on going towards negative infinity. So then this is going to be my solution. I need a starting point and an ending point. So where do we start? Remember, we read from left to right. So we are starting at negative infinity. And then where do we end? Do we end at 4 or do we end at 10? Well, since we are going from negative infinity, and it is going to keep on going, it's going to go past 4, it's going to stop at positive 10. So that's where we end off at. We don't need to write the 4 there because that positive 10 is the end point there. So we'll write positive 10. At negative infinity, we give it a parentheses, and at positive 10, we give it a square bracket because that is a less than or equal to, meaning that that 10 is included. All right, so number 5, we have x is less than 4 and x is greater than or equal to 10. So I'll write 4 and 10. X is less than 4. We have an open dot at 4, and then we shade to the left. And then at 10, it's a closed dot, and we're shading to the right. Since we have an and situation, we're looking at where these two inequalities overlap. Do these two inequalities overlap? No. So that means since these two inequalities do not overlap each other at all, this is a no solution problem. So the interval is no solution because there is no interval at all. All right. Let's move on to number 6. X is less than 4 or x is greater than or equal to 10. So I'll write 4 and 10. Since it's x is less than 4, it's an open dot. I'll be shading to the left. And at 10, we have x is greater than or equal to 10. It's a closed dot. And we're going to be shading to the right. All right, so it's an or. We're going to shade everything that either individual inequality touches, so all the x values involved in number 6. So we have an open dot at 4 and a closed dot at 10. At 4, I'm going to be shading to the left, and it's going to go towards negative infinity. And then at 10, it's going to shade to the right, and it's going to go towards positive infinity. So when I'm writing my interval, I'm going to be looking at what I'm shading on the number line. So we're going to read from left to right. Where do we start? Well, we start at negative infinity, and then it's going to end at 4. So negative infinity, comma 4. All right? So regular parentheses at negative infinity, and regular parentheses at 4. But we can't neglect this stuff because this is the stuff that we shaded on the number line. So we're going to read from left to right there. But before we do that, we need to make sure that we include this symbol, the union symbol, because we have an OR problem. So I'm going to write union, and then let's look at the interval from positive 10, and it seems like it's going towards positive infinity. So 10 comma positive infinity, 10 gets a square bracket, and then positive infinity gets a parentheses. So the interval is from negative infinity to positive 4 union 10 to positive infinity. All right. Okay, so we understand the basics now. What we're going to do is we're going to involve solving inequalities now. Understanding the difference between and or compound inequalities is the key to solving them. Solve compound inequalities separately and graph each individual inequality. Then decide whether your solution is where the graphs overlap, which is an and type of situation, or everything being touched, which is an or situation. Now, remember, to solve inequalities, we follow the same steps as solving equations. However, the only extra thing that we need to remember is that when we multiply or divide by a negative, we have to flip the inequality. So looking at number 7, we have 5 minus 2x is greater than or equal to 6, and 2x minus 8 is greater than or equal to 3. So I'm going to look at this inequality first before I look at this. I'm going to solve this inequality like I'm solving for x. I'm going to subtract both sides by 5, and I have negative 2x is greater than or equal to 1. Now, I'm going to divide both sides by negative 2, and since I'm dividing by a negative, what happens here is that I'm going to flip the sign. So x is less than or equal to negative 1/2. All right? And then we have 2x minus 8, which is greater than or equal to 3. We're going to add both sides by 8. And we have 2x is greater than or equal to 11. And then I'll divide both sides by 2, and I have x is greater than or equal to 11/2. And I don't need to flip the sign here because I'm not dividing by a negative. So we have x is less than or equal to negative 1/2, and x is greater than or equal to 11/2. What do I need to put first? The negative 1/2 before the 11/2. So at negative 1/2, since it's an x is less than or equal to, it's a closed dot, and I'm going to be shading to the left. And at 11/2, since it's an x greater than or equal to 11 over 2, it's a closed dot, and we're going to be shading to the right. Now, look at our conjunction. We have the word and. We are looking to see if these two inequalities overlap. Do they overlap? No. So what do we need to put if they don't overlap? No solution. All right. Number 8, 6 minus x is less than or equal to 3 minus 2x, or x plus 3 greater than 3x minus 1. We are going to look at this inequality first, and then we'll look at this. All right. So 6 minus x less than or equal to 3 minus 2x. I'm going to go ahead and add both sides by 2x. So I have 6. Negative x plus 2x is plus x, which is less than or equal to 3. Then I will subtract both sides by 6, and I get x is less than or equal to negative 3. Now, looking at the other inequality, I'm going to go ahead and subtract both sides by 3x. And notice that I like to have my x on the left-hand side of the inequality. So I have x minus 3x, which is negative 2x, plus 3, which is greater than negative 1. And then I'm going to subtract both sides by 3, and I have negative 2x is less than negative 4. But I'm going to be dividing by a negative, so I will divide both sides by a negative 2, and what happens here is that that greater than sign is going to become a less than sign. So x is less than 2. So we'll write negative 3 and positive 2. Negative 3 is included, and we're going to be shading to the left because it's a less than or equal to sign. And then at 2, we have an open dot, and we are going to shade to the left because it's a less than situation. So, since we have an or situation, we can analyze the problem. We are going to look at x is less than or equal to negative 3. So I'm going to start at negative 3, and it's going to go towards negative infinity. And then for x is less than 2, we have an open dot here, and we are going to keep on going and going and going towards negative infinity. However, as I approach negative 3, it doesn't really matter what happens. It's already included anyways. But if this was an open dot, that open dot becomes a shaded dot, but it doesn't really matter because it's already shaded to begin with. So going back to this, we're going towards negative infinity. So all of these x values are going to be included on the graph and as I write my interval. Except that too, but we need to write that anyways because it's an open dot and we have to give it a regular parentheses, right? All right, so here we go. We have negative 3, it's a closed dot, and we're going to be shading to the left, and then at 2, it's an open dot, and we're going to be shading to the left, and remember, it's going to go to negative infinity as well. We're going to read this from left to right, so we start at negative infinity, and we are going to end at 2, not negative 3. We're just looking at the stuff that's being shaded. We're going to look at the rightmost number that is involved in the shading process, right? So we are going to give negative infinity a parentheses and at 2 a regular parentheses as well. All right, so the interval is from negative infinity to 2. All right, we have 2 more problems to go. We have number 9 and 10. Number 9, we have negative 5 less than or equal to 1 plus 2y less than 3. Now, notice that you don't see an and or, but you're going to have to believe me on this one. This is an and problem. This is an and situation. This just means that negative 5 is less than or equal to 1 plus 2y, and 1 plus 2y is less than 3. So how I'm going to solve this problem is I'm going to group these two together, and I'm going to group these two together as well. So I'm going to write this as negative 5 is less than or equal to 1 plus 2y, and 1 plus 2y is less than 3. And then we're just going to proceed as normal. So focusing in on this inequality here, that negative 5 less than or equal to 1 plus 2y, let's go ahead and subtract both sides by 1 so I can get that 2y by itself. I have negative 6 is less than or equal to 2y, and then I'm going to divide both sides by 2, so I have negative 3 less than or equal to y. Now, I don't like how this is written. Remember, I like to have my variable first, then the inequality, then the number, meaning that since the y is bigger in this situation, I like to have the y written on the left-hand side of the inequality and then have the number on the right-hand side of the inequality. So I'm just basically rewriting this. And then looking at this other statement, that 1 plus 2y less than 3, let's subtract both sides by 1. I have 2y less than 2. Then I'm going to divide both sides by 2. I'm not dividing by a negative, so I don't need to flip the sign at all. So I have y is less than 1. So here are the two inequalities that I'm going to be dealing with. Our main characters are negative 3 and positive 1. Y is greater than or equal to negative 3. That's a closed dot, and we're going to be shading to the right. And at 1, that y less than 1, it's an open dot, and we're going to be shading to the left. And remember, we're dealing with an and situation. We're trying to see where these two inequalities overlap. And we can see that they overlap here. So let's go ahead and put everything together on this number line here. So negative 3, it's a closed dot. And at 1, it's an open dot. And then we're going to be shading between these 2 points here. And then the interval, we read from left to right. We're starting at negative 3 this time. And then we're going to end at 1. At negative 3, it's going to be a square bracket. And at 1, it's a regular parentheses. All right, so let's go ahead and move on to number 10. 3 minus 2p is greater than or equal to 7. Or 12 minus 7p is less than negative 2. Here we go. We're going to go ahead and get that negative 2p by itself. So I'll subtract both sides by 3. I have that negative 2p is greater than or equal to 4. Then I'll divide both sides by negative 2. And since I'm dividing by a negative, that sign is going to be flipped. So it's p is less than or equal to negative 2. Looking at 12 minus 7p less than negative 2, I'm going to subtract both sides by 12. And I get negative 7p is less than negative 14. And then I'll divide both sides by negative 7. Since I'm dividing by a negative, we have p greater than negative 14 divided by negative 7 is positive 2. So the main characters are negative 2 and 2, so I'll write negative 2 here and positive 2 there. Since it's p less than or equal to negative 2, we're going to have a closed dot, and we're going to be shading to the left. And then since we have p is greater than 2, it's an open dot there, and we're going to be shading to the right. Since this is an OR problem, we are not concerned about the overlapping between the two inequalities. We are just concerned about what are all the x values involved in number 10. We have a closed dot at negative 2, and we're shading to the left, and it's going towards negative infinity. And at 2, it's an open dot. We're going to go ahead and shade that to the right. We're going to read this from left to right. We're just looking at the stuff that's being shaded as we are writing our interval. We are going to start at negative infinity, and then it's going to end at negative 2. So negative infinity, comma, negative 2. Negative infinity gets a parentheses, and at negative 2, since it's included, it's a square bracket there. But we're not done yet because we have to look at this stuff here. So we need to write union, because it's an OR situation. And then we write 2, since that's where we're starting at for that inequality, comma, and the graph shows that it is going towards positive infinity. So I'm going to go ahead and put positive infinity. All right, so at 2, it's a parentheses, and at infinity, it's a parentheses there.